Hello pre-algebra scholars, this is lesson 22, session 4, and our objective is the same as it was last time, so I'm not going to make you rewrite it, but we are doing operations with scientific notation, and this time we are specifically looking at multiplying and dividing in scientific notation. Let's jump right in. We have a neat problem here. It says, over time, the ocean floor moves apart along underwater mountains and trenches. The mid-Atlantic ridge moves an average of 3.5 times 10 to the negative 2 meters per year. So not very much, just a tiny bit, right? Less than a meter per year. The eastern Pacific ridge has moved 6.6 times 10 to the 6th power meters in 6 million years. So if we put this over 6 million years, it adds up to be quite a bit, right? Okay, let's answer this first question. How many meters has the Mid-Atlantic ridge moved in 6 million years? So we know how far the eastern Pacific has. We want to know how many the Mid-Atlantic has moved in 60 million years. Write your answer in scientific notation. So we obviously, I've got this amount per year, and we want to know over this many years. How do we do that? Well, we multiply because it's a multiple amount of times. If we want to extrapolate over a good extent of time, that's always going to be multiplication because this happens every single year. So we need to figure out how to do 3.5 times 10 to the negative 2 times 60 million. I'm going to write that in scientific notation. 6 times 10 to the, what would give us million? 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000, times 10 is 100,000, times 10 is a million. Okay, we need 6 of them. Okay, so that is our 60, we need 60 million, not 6 million. So it's going to be a 7 right here, a 7. Okay, so we need to figure out how to multiply these together, okay? And I'm going to tell you this actually is pretty easy, okay? It's pretty easy. Whenever we multiply things in scientific notation, we're going to do these numbers in front, just like we did with division, times these powers of 10, okay? Since this is all multiplication, there's a multiplication property that you should have learned in like 5th grade that says it doesn't matter what order I multiply things in if it's all multiplication. I can reorder it however I want. So that's exactly what I'm going to do. I'm going to reorder it however I want. I want to do this 3.5 times 6 first. And then I want to do this 10 to the negative 2 times 10 to the 7th power second, because if I do this, I'm going to maintain my 10 to the power of something. Okay, so we need to do this. 3.5 times 6. What is that? 3 times 6 is, well, I'll just do it over here. 3.5 times 6. 5 times 6 is 30. 6 times 3 is 18, 19, 20, 21. Add my decimal. This equals 21 times 10 to the, look, this is like bases. We're multiplying them together, so you need to add the exponents. We need to add the exponents. Okay, so negative 2 plus 7, that's the same as 7 plus 2, or 7 minus 2 is 5. Now this isn't proper scientific notation, is it? We need the decimal to move from here to here. When we move to the left, it's going to increase our exponent. We moved one time, so it's going to go from 5 to 6. And that is our new answer. Let's write that as a statement. The Mid-Atlantic Ridge has moved 2.1 times 10 to the 6th meters in 60 million years. Well, that's quite a lot, right? That's like, how many meters is that? We're going to move this 6 times. That's 2,100,000 meters. Holy smokes, that has moved quite a bit over this really long period of time. Okay, so we are going to keep chugging along here. So we have a second question now, okay? We have a second question, and it says, how many times, how many times? You know this. We've talked about this. This is division. About how many times as many meters has the Eastern Pacific Ridge moved than the Mid-Atlantic Ridge in 60 million years? Okay, well, we can do that. We're comparing the Pacific Ridge right here, 6.6 times 10 to the 6th. We're comparing that to our new distance that we just found. Well, this looks pretty easy. We know that we can split this up again, okay? We are going to do the left side and then the right side. 6.6 divided by 2.1. 6.6 divided by 2.1. What is that? That is... that is like almost pi, my friends. That's like, it's like 3, let me check, that seems crazy. Yep, okay, it's like basically pi. 3.14, and what's happening over here? We subtract the exponents when we divide. Subtract the exponents, so we get 10 to the 0th power, okay? Which is 10 to the 0th power is 1, so this is like 1.14. And this said to estimate, so we're just going to say 3, okay? How many, the Eastern, or the East Pacific Ridge, oh, it says rise, not ridge, rise, has moved about 3 times the distance of the Mid-Atlantic Ridge. Okay, we just did multiplication and division. We got really good notes on how to do this, okay? In both ways, we're kind of splitting up exactly what we're doing. So this just says kind of basically the same thing. It just shows you a little bit differently, but it's basically what we did. Just a really clean look at what we did. A couple questions to answer, and then we'll be done with this. We did this. We did this. We answered that. What properties of integer exponents did we use? Well, when we multiply in scientific notation, we end up multiplying like bases. So what do we do when we multiply like bases? We add the exponents. And when we divide in scientific notation, we end up dividing like bases. And when that happens, we subtract the exponents. That's kind of stuff you already know, right? But every time we multiply in scientific notation, we're going to have this. We're going to be adding exponents. Every time we divide in scientific notations, we're going to have this. We're going to subtract the exponents. Okay. Number 4. What must be true about the powers of 10 when adding and subtracting numbers written in scientific notation? We have to make sure when adding and subtracting, the exponents have to be the same, or we have to make them the same, right? They have to be the same, or we have to make them the same, or we're just going to write it in standard form. Is this true of multiplying and dividing? Not true of multiplying or dividing in scientific notation. Okay? When we multiply or divide in scientific notation, we're going to use these ideas, and we don't have to go through all the work. So multiplying, dividing in scientific notation is a lot easier. Okay, this is an opportunity for you to reflect on what you learned and write about the strategies if you need to. And then you should know what to work on next. Thank you.